In this video tutorial, I'll show you how to find the inverse transforms of a function. This is question number 3. The question reads, find y if the Laplace transform of y is equal to 12 over s squared minus 2s minus 8. And I've given this question a difficulty rating of hard relative to the other two that we did. In question number 2, we had a similar example where there was a quadratic in the denominator position. And we took a chance by converting the standard form quadratic, which is what this quadratic is in, into the vertex form, and we matched it with number 24, and from there we got our answer. We can do the same thing here, but I'm going to tell you ahead of time that if you change this into vertex form, you're going to have a really hard time later on. So there has to be another way to tackle this. There's only so many things you can do with quadratics. So if I look at this carefully, you'll notice that this is factorable, and you can find two binomial factors that will give you this. What two numbers multiply to negative 8 and add to negative 2? The two numbers that I'm thinking of are negative 4 and 2. And now that I found these numbers, I can rewrite this as 12 over s minus 4 and s plus 2. The left side will be 12 over s squared minus 2s minus 8. The next technique that I'm going to use is partial fraction expansion. And what that does is it takes a condensed expression and expands it for each factor that's in the denominator. If you're confused by that, here's what I mean. So we have two factors in the denominator, and each of these factors is going to get an arbitrary constant. So this factor is going to be represented as a over s minus 4 plus b over s plus 2. Now on the right side here, if I find a common denominator, I'll end up with a times s plus 2 plus b times s minus 4. And by taking a common denominator, we'll have s minus 4 times s plus 2. Now I want you to pretend that this is down here. Since the denominators are the same, we can clear the denominators, leaving us with 12 on the left side is equal to as plus 2 times a plus b times s minus 4 times b. Now we need to find what a and b are equal to, and one way to do that is to collect like terms. This term and this term are like. We have a times s plus b times s plus 2 times a minus 4 times b. I'll factor these two terms for s. We get a plus b plus these two terms being factored is 2 times a minus 2b. Setting this equal to 0, I end up with 2 times a minus 2b is equal to 12. I'll solve for one of these letters and substitute it back into here. Let's do it quickly. We get 12 divided by 2 is 6 is equal to a minus 2b. Bringing that over, we get 6 plus 2b is equal to a. I'll substitute that now into a, where I get 6 plus 2b plus b is equal to 0. This is equal to 3b. Bringing that over makes it negative 3b. And 6 divided by negative 3 is equal to negative 2. We just found out what b is equal to. To find out a, of course, you can bring this negative 2 into here, and you end up with a is equal to positive 2. I'll change this with positive 2 and this with negative 2. And now we have two that model this frequency function, 1 over s minus a. Our a here will be minus 4, and our a here will be positive 2. The only problem is that we have a 2 and a minus 2 where there should only be a 1. So when you write your answer down, this will become e to the power of negative 4t plus, again, e to the power of 2t. To compensate for the fact that we had a minus 2 here, you'll write it down as a coefficient, and this 2 will be written as a coefficient. So you have 2 times e to the power of negative 4t minus 2 times e to the power of 2t. This is equal to y or f of s. And there you have it. That is how to find the inverse transform of a function.